In previous section, I showed you how to create internal and external BGP neighborship between different routers. And now I want to add some prefixes to my BGP database and advertise these to other routers in other autonomous systems. Let's go to ISP1 and check some of these IP addresses and prefixes. I have added some interfaces to ISP1, and if I go to IP addresses here, you can see that I have loopback 11, 12, 13, 14, and 15, and all of them start with 100, 100. All of them are 24-bit net mask, and they are all active and connected interfaces to this router. Now I want to advertise these to other autonomous systems, but not through OSPF or RIP or any internal gateway protocol. Actually, I'm going to use BGP to advertise these to other networks. So how can I do that? You can see that under BGP we have a networks tab, and this is essentially different from what we see in OSPF and RIP. In these two protocols, we use networks to add interfaces to OSPF or RIP process. If we add a network here, the router will search the interfaces and checks their IP addresses. And if there is an IP address that falls under the range that we have entered in networks, that interface will go under the routing protocols process, for example OSPF process. And in OSPF, for example, it starts sending and receiving updates and hello messages or anything, creates neighborship and things like this. In BGP, networks are not meant to do this. Networks are just prefixes that we are going to advertise to other routers. So how can we make sure that these prefixes will be sent to other routers? If we go to IP routing table, we can see some prefixes here. And if we want to have a prefix in BGP database, it should be in routing table. So this is essentially very important. So I have 100, 111 through 100, 115, and I want to advertise all of these. And you can see that all of them are 24-bit net mask. So I go and add a network like this, 100, 100, 11, 0/24, and click on OK. Now if I go to one of my neighbors, here my neighbor is router 4. If I go to router 4, and if I open IP routing, you can see that 100, 111, 0/24 is here. It is advertised using BGP, and it's, in fact it is external BGP, and based on the distance of 20 I can tell that this is external BGP, and I can easily reach that. If I try to ping this using tools ping 100, 111, I can reach that. You can see that this is successful. Okay, I stop and close this. Now I want to add another route here. Based on a standard, if you want to add a prefix to networks, it should comply with what you see in your IP routing table. So if I try to add 100, 100, 1200/32, actually standard says that this won't work, and because there is no such net mask in your routing table for this prefix is not going to be advertised. But let's see what happens in MikroTik. I click on OK, and you can see it has been added to my network. I can go to router 4, and I can see that this is advertised. So this is a little different from what you see in other platforms such as Cisco. In Cisco, you completely adhere to the standard and you do not advertise such route, but here, this is advertised. Okay, let's go and add other networks, and because I want to be, quite clear, I prefer to change this to /24 and be a good guy. I click on OK. I add another one, 13. I add 14. And I add 15 here. This is going to be 15. Now I have added all of these prefixes. They are gonna be advertised, and I can see that all of them are here and all of them have a distance of 20. That means they are externally advertised to us. So let's have a look at routes that we have add here. If I go to advertisement tab, I can see that these are sent to router 4. These are my advertisements to router 4. And one piece of information is so important here. The origin is IGP. We have three different types of origin. One is IGP, the other one is incomplete, and the other one is unknown. Actually, no, EGP. Actually, we do not see EGP because this is too old. We only can see incomplete and IGP. And when should we see incomplete? Let me show you this. I go to networks and I remove all of these. I select one and press shift and select the last one and press on this minus button. Instead of adding these routes through network, I can redistribute them into BGP database. And redistribution is another type of adding networks and prefixes to BGP database. I can go to instance, double click on this instance, and here we can see redistribute connected, static, RIP, OSPF, or other BGP. I want to redistribute connected because these are the interfaces that are connected to this router. And click on OK. Now this time if I go to advertisement again, I can see that I am sending all of these, and actually because I have selected to send all of connected interfaces, I can see every interface that has an IP address attached to that. But the important thing is this: now the origin is incomplete. That means we have redistributed these prefixes and we do not know what the exact origin of this is. In network we know that the origin was interior gateway protocol, such as for example RIP or OSPF, but here we are not sure about their origin, so we add an origin of incomplete to this router. Okay, what is the difference between these advertisement and the other advertisement? Actually there is no difference. If I go to router 4, I can still see these routes here, and one of them are not active, and this is because I don't have a next hop reachable for this prefix. And I'm going to correct this in a moment. Okay, actually you can see that all of them again are advertised with a distance of 20. And all of them are active, all of them are here, so there is no difference actually between what we see in Redistribute and network, except the origin that is different in these two cases. So why this is not active? As I told you, this does not have reachability to the next hop, that is 100, 148, 100, and I can make sure that this is the reason by type in 100, 148, 100 and try to ping it, and you can see that, and of course it is reachable. So what is the problem with this? I can close this and double click on this, and no, this is quite reachable. So this is let me remove this, close on it. This is not reachable because this is not active because we have a connected route. Now that's the problem. And if we have a connected route, that will be preferred over this. And you can see that this is BGP route and it is installed in this case, but because we have a connected route for this, we do not need to have this active, so we deactivate it. Okay. This is okay. Let's go to other routers and see if there are these advertisements in OS router. I want to check router 2, but before going to router 2, I want to see if router 4 advertises these prefixes to router 2. I can go to BGP and go to advertisement. As you can see, I have some of these routes advertised to router 2. And again, you can see the origin is incomplete. The AS path is AS100. That means it has reached from AS100 directly to us, because we only see one AS path here, and I'm going to talk about AS path in detail in later sections. Let's go to router 2 now. If I go to router 2 and try to see IP routing table, by opening this, you can see that I have all of these routes here except one fact. They have a distance of 200. And why is this like this? Why is the distance 200? That's because these are advertised through an IBGP neighbor to me. And if I receive routes from an interior BGP neighbor, I mark the distance 200. That is, this is the least attractive route for me to reach to these prefixes. I prefer to go for other routing protocols, and if there is none, and in this case you can see there is no other routes except these, I prefer to go for these. Okay, you can see that they are active, and this is because the next hop is active, and you can see the next hop is 192, 168, 24, 104. And this is another characteristics of external BGP. Whenever you receive a route from an AS, when changing AS, you change the next hop and you set yourself as the next hop. That means, although for router 4 next hop is ISP4, because there is an AS change here, if router 4 wants to advertise this to router 2, it will change the next hop and it will tell router 2 that to reach to these prefixes you need to select me as next hop. And this is interesting because in internal BGP neighborship there is no such thing. So router 2 receives router 4 as next hop, and although router 2 sends the routes to router 1, router 1 still sees router 4 as next hop, because this is an internal BGP neighborship between router 1 and router 2, and router 2 does not change the next hop for router 1 unless you want to do this manually, and I'm going to show you this. Okay, go into router 1 and checking IP routing table. If I go to IP routes, I can see that these routes are not here. Although I want to receive this, I do not see this here. Why is this like this? If I go to router 2 and check BGP advertisement, I go to routing BGP and check advertisement, I can see that I am not sending these to router 1. And why is this like this? Router 4 sends them to router 2 because these are the routes that router 4 has received from an external AS. So it sends them to router 2. But router 2 does not send them to router 1 here. Why is this like this? This is because router 2 has received the routes from an internal BGP neighbor, and the default is not to send internal BGP routes to other routers. So what should I do when there is such a behavior here? I can go and select different approaches to solve this issue, and in next section I want to talk about this.